Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our string find function. This is part of a larger series involving the core.c and core.h library that we're ultimately going to use in multiple projects. This assumes that you've already watched the char find video and also have some of your basic string functions like string length working, as well as a basic understanding of your string upper and string lower functions. So to begin with, we're going to set up some temporary variables, and we're going to also discuss a little bit about what our contents, search, and locations vectors are, as well as a reminder of the maximum number of locations that we are going to be able to find within a string. So let's begin first by talking about what each one of these are. So to begin with, our contents is the string to search in. And our search is going to be the string to search for. Now, the important thing to note, unlike the char find example, is that both of these are strings and are assumed, to have a end of string character associated with them. So in char find, we were looking at a single character and we were looking for it inside of a character vector or potentially a string. In this particular case, we are going to ensure or must ensure that these are strings. So therefore, both of these must have end of strings associated with it. So must have the end of string. Now, as such, what we can do now is we can create a couple of temporary variables that we're going to use. We're going to start off. The first one is going to be contents length. And the second one is going to be the search length. And likewise then, what we want to do is we want to go ahead and create a contents index and a search index. All right, so we have a contents index and then a search index. And you're going to discover that a couple of these variables are simply convenience variables, meaning that we could just make a call to our string length function, but it's easier the first time through just to go ahead and use these temporary variables, and then you can optimize later on. We also want to create a flag that tracks whether or not we have found a match. So we're going to just simply call this a match. And what we'll see is that we'll initialize this to either 0 or 1, depending on how we set up our logic. The last thing that we want to do before we jump into this problem is we want to talk a little bit about the behavior that we want to see in our search capacity here. And so let me give you a couple of examples here. So this is going to be a contents equal to, and I'm going to use sort of pseudocode here. So we're going to say the contents is equal to banana, and the search is going to be equal to the letters NA. And so the idea here is that if we were using zero-based indexing, that we would wind up with a locations vector that would ultimately have the value 2 and the value 4, because that represents, if you think about it, 0 is going to be B, 1 is going to be A, and then the N is going to represent the index equal to 2, or the first N rather, and then the second N is going to represent the second N. So the 4 is going to represent the second N. And then the other example that we want to quickly take a look at is if contents is equal to something like IEEE meeting, and I'm intentionally doing this one in all caps because we are not going to be handling upper and lower case. We're going to say that it is case sensitive for this particular example. And I'm going to search then for a substring of EE. And so what we want to do now is we want to decide on the behavior, particularly what happens with the two E's in IEEE. And so we would probably all agree that the first value or the first match is going to occur at index equal to 1. But then the question is, what do we do with those duplicate EEs? So there's two EEs in their search string and 3. So do we then follow that up with 2? Or do we jump straight to meeting? And so the normal behavior, for instance, if you use Microsoft Office, is going to be that it is not going to pick up this second EE. In other words, there's not going to be overlap between a match. Instead, what we want to do here is we want to look at this from, once again, zero-based indexing. So this is going to be 0, 1, 2, 3, 4, because we have to include the space, 5, 6. So the result should be 1 and 6, provided I've got my indexes right. So the last little comment then is this is going to be case sensitive for now. All right, so let's go ahead and get started. We may need some more temporary variables. Particularly, we're going to want to include a count because ultimately we're going to want to return the count. And so we need to initialize some of these. We can begin by initializing the context's length rather. And what we're going to do is we're going to use our string length function that we built in an earlier video to simply measure the length of contents. We're going to do the same thing now with our search length, and we're going to initialize it to the length of the search string using our string length function. And we can go ahead and initialize our contents index equal to 0. We're going to go ahead and use while loops in this case. You can also use for loops if you wish. So our search index is going to be equal to 0. Our match, we're going to be optimists for this one. And we're going to say that our match is equal to 1. And we're going to initialize our count to 0. Now, the way that you can simplify this a little bit is by doing some good error checking in the beginning. And if anything, we're going to be a little excessive. We're going to check each specific thing separately. But the first thing that we want to check is that our contents length and our search length are both greater than 0. So the first thing we want to do here is simply say, if contents length less than or equal to 0, there should not be a scenario where it winds up with less than 0, but at the very least, we're going to check to see that it is not equal to 0. So if it's less than or equal to 0, we simply want to print to the console error, no valid contents. Perhaps not the friendliest message, however, it does get the point across. You can always improve on that later. We want to follow this up with another else if. We want to check that the search length is greater than 0. So we check to see if the search length is less than or equal to 0, in which case we once again follow it up with a error message, error, no valid search. And you can probably go ahead and make this a little bit nicer, or at least a little more informative, and say no valid content string and then no valid search string. Now, this only gets us so far. The next thing that we want to check is that our contents length is in fact greater than or equal to our search length. Because if the search length is longer, there would be no way that we could find a match within the contents. And so your next check is going to be that search length, if search length is less than your contents length, perhaps we can make it this one a little more useful or a little more informative. Error, your search string is shorter than your contents string. And once you've made it through those 3 checks, we're essentially now ready to see if we can find our search string within our contents string. So what we do now is we start by looking at the content. So we start off at the 0 index of our contents, and then we start looking at the 0 index of our search string. And so to help you with this, to understand how this works, take a look at our NA in banana. So essentially what we do is we compare the N to the B. In that particular case, it's clearly not a match. And then we move on to index equal to 1 of both of banana. And then we compare index 1 of contents to index 0 of our search string. We compare our N to our A. Those also don't match. We grab another character out of our contents. So now we're at index equal to 2, and we compare it to index equal to 0 of our search string, and the N's match. So now we're presenting with a challenge in that how do we compare the next characters and the next characters and so on until we either run out of characters to compare or we discover that there's no longer a match between them. So in this case, what we'll do is we'll compare the A, the second A, particularly in banana, or index equal to 3 with the A in our search string, or the search index equal to 1. So to begin with, what we want to do is we want to set up our while loop. And remember that we have already initialized our contents index. That's a critical step here. So we want to start off, we want to build a while loop here. And so while our contents index less than our contents length. Okay, we're going to come back to this one in just a second. We're actually going to make a little bit of a modification here on this one. But we'll start off with our contents index less than our context length. All right, we'll shift those parentheses in just a second. Now, inside of this loop, we want to reinitialize every time that our match is equal to true. We're going to be optimists, and we can afford to be optimists because we're guaranteed that there is going to be at least one character to compare by virtue of how we set up our logic here. So we're going to start off, our match is equal to true, so we're going to assume true. And what we want to do now is we want to initialize once again our search index. So search index equal to 0. And we want to have an inner while loop that says while search index less than the search length. But more importantly, we want to have a second condition that says while match equal to 1. So we're going to look at both of these conditions. So while match is equal to 1 and search index less than search length, we will compare characters. And specifically what we want to do is we want to have an if statement that compares the contents square brackets contents index. And this is where it gets a little unusual. Not only do we want to start off comparing the contents index or the value of the contents at contents index, but we want to actually add to it the search index. This will make a little bit more sense when we essentially look through or look at some scenarios here. And we want to compare that value with the search string and the index, the search index. Okay, so if those two values are equal, we still have a match. Else, they differ, no match. And so, very least, what we want to do is we simply want to say match equal to 0. Now, before we go too far, let's take just a second to think about what this means here. So, in order for there to still be a match here, so we'll start off with our search index equal to 0 and our contents index equal to 0. So the idea here is that I'm comparing the B in banana to the N in the search string. Both of those are 0 index. So our contents and the 0th index of that contents to the 0th index of the search string. Now, if we don't have a match, then we simply say match equal to 0, and we'll handle that in just a second what we do here. But continuing on now, if we get to the first N in banana and we compare it to the 0th index of the search string, essentially what we would have here is contents index equal to 2 and the search index equal to 0. And so essentially we are comparing the second index or contents equal to 2, the index of the contents equal to 2, and the 0th search character. And so hopefully you can see now essentially what we're going to do is we're going to use this as a starting point to compare the search to the contents. Now, if we still have a match, what we want to do is we want to increment our search index. So that allows us then to step forward not only in the search string, but also in the contents string. Now, if we manage to make it outside of our while loop, in other words, if we escape out of our while loop, we have two possibilities. It means either that we no longer have a match, or that somehow we have looped through enough of the characters such that the entire search string matches a portion of the contents. And so essentially, if we've managed to make it outside of this while loop, we have only to check that match equal to true. So if we've successfully made it out of the while loop with match equal to true, we have found a match and need to store it. Well, as I mentioned earlier, we want to be careful about how many locations to store, but for right now, what we would do is we would simply say locations, square brackets, count is equal to our contents index. In other words, the starting point in our contents vector, and we want to simply then increment the count, much like we did in our char find. In the else scenario, then what this means is that we simply have to move forward in both the, in the contents string. So in this case, we simply say contents index plus plus. Now this presents a interesting question here. What do we do in the true branch? In other words, How do we move forward? And particularly, how much do we move forward? It's clear when we're looking at our NA in banana that if we do not find a match, we simply start over with the next character. So we simply increment the contents index plus plus. However, what's not so clear is how do we move forward when we do find a match in either the EE in IEEE meeting or the NA in banana. So let's think about this. If we had found the match of NA in banana, there is no reason for us to go back and check the N to the A in banana. Instead, what we want to do is we want to jump forward completely past the end of the search string before starting a new search. And to do that, what we can do is simply, instead of incrementing the contents index by 1, we simply say the contents index is equal to the contents index plus the search index. And if you recall, the only way for us to get to match equal to 1 and outside of our while loop is if all of the characters matched. Well, that means that we would rely on the second half of our condition in our while loop, which means that the search index would now be equal to the search length, which means then that we would effectively have added 1 to the highest index in our search index or highest valid index. So long story short, by doing it this way, we are essentially incrementing the +1 that we would do here, as well as the index, the search index. So if you think about it, if the search index or the search length was 2, then our search index was 0 and 1, and we would go 1 past that. So we would effectively be adding 2 to the base contents index. So in other words, in this particular case, if we're going back to our banana example, we would be starting at 2 and we would be adding 2 to it because that was our search string length, which would allow for us to restart our search at index equal to 4. So we've got 2 more things left to tidy up and then we'll be done here. I said initially that we were going to come back to this contents index less than contents length. Let's think about this for a second. We could blindly just loop through each one of the characters all the way to the end, and therefore we would try to compare this A to the entire search string NA, which would result in us going past the end of our contents. Or what we can do is stop our outer while loop before we get too far in the contents string. Specifically, if you take a look at the word banana, we'll see here that it's actually 6 characters. And the length of our search string is 2. So we would not need to go any further than the 5th character, or actually we could still search the 5th character and the 6th character for the pattern. Now, how we would accomplish this is by stopping our outer while loop by leveraging not just the contents length, but also the search length. And then this is the part you're going to need to think through a little bit. We would add 1 to it. So let's go through this scenario for just a second. So remember that C is 0-based indexing. So in this case, if our content string was 6 characters long and our search string was 2 characters long, that would mean that this would be index 0 through 5. Now, our contents length is 6 and our search string length is 2. 6 minus 2 is going to be 4, which means that our loop would stop at contents index 3, or specifically when it became contents index 4, it would not run. Hence the need to shift it by 1. And you can draw this out to convince yourself, or you can simply just count out how many iterations or how many starting iterations you would have here. So this handles that shift right there. The second thing that we want to handle is the number of locations, and that is handled by the count. So in other words, once we have exceeded the number of matches that our locations vector can handle, we need to stop searching. And to handle that, we do this also in our outer while loop by putting a second condition. Doesn't really matter whether you check it first or second, because both of these will need to be true. And that will simply be that our count is less than, in this case, we're leveraging our n max that we have in our core.h. So as long as these two conditions are met, then this outer while loop will run. And then once again, lastly, when we're done, we're going to have a return value of count, but more importantly, we're going to update our locations vector. So let's go ahead and build this, and then let's come up to our main and let's test this out and see if we have any bugs. So up here in our main, in our core driver, we'll leave this where it's at. If anything, what we'll do is we'll slide this over to the right. We've already got some examples that we can try. So in our core driver, what you can do once again is you can build the switches such that you can test this from the command line, or you can simply build a demo function like we did in an earlier video called string demo and test it separately. What I'd like to do is I'd like to create another option here in our else if triaging of our command line arguments, and that I would like to provide both the content string and the search string. So in other words, we're going to have 4 arguments. So we're going to start off with else if argc equal to 4, and our string compare I for argv will simply be, just like as in the previous example, will be the name of the function. So in this case, I'm going to say string underscore find. And if that is equal to 0, we're going to assume that we've got some valid arguments in our argv2 and our argv3. Now, unlike the previous example, I'm not going to bother to use the string copy to temporarily copy those values. Instead, what I'm going to do is I'm going to go ahead. I think I accidentally pushed a line down further. Didn't mean to. I'm going to leave this here. What I'm going to do now is I'm going to simply pass my argv2 and argv3 directly to my string find function. So we're going to have results equal to string find. And for the contents, I'm just going to pass argv2. For the search, I'm going to pass argv3. And then for the locations vector we created earlier in another video, let's see if we've got this here. Actually, I believe we may have used this inside of our string demo. So if anything, what you want to do is you want to recreate it. So we're going to go ahead and copy this, put this in our main. And then before we forget, why don't we come down here to our help and make a little note about how we want to run this. And so we'll start off by saying string underscore find. And particularly, how about if we include the example that we were just doing, and that is the word banana and the search string of NA. All right, so let's go ahead and build this, and let's see if we've got any mistakes in our logic. Probably the other thing that would be nice to do here is to go ahead and print out what the results actually are. How about if we print out the count? And that would just simply be %d. And that is the results variable. And then the other thing that we want to do is we want to simply loop through each one of the locations. So how about if we create a temporary variable called index or location index, doesn't really matter. And we'll say for index equal to 0, index less than results, index plus plus. And what we'll do here is we will simply printf the index location and then the value or the location of the substring within the string, which will also be a %d. In this case, the first one will be index, and the second one will be locations square brackets index. And let's build it one more time. Let's come out here to the command line. Go ahead and change directory over to your core demo. And core demo.exe/string_find. And we want to look for banana in an NA in banana. And our count is equal to 0. So we've got some sort of logic issue here. Let's go take a look at it. All right, so let's go over to our core.c and we'll see where our problem is in our string find. So, yes, that's actually what we wanted here. I misspoke. We want to check. We always want our search string to be less than our content string. How about if we try this way, our contents length less than our search string? Logic got me here. All right, so the content string is shorter than your search string. All right, let's go ahead and build this. It's good to know that our logic might have been wrong, but it was at least working. So let's go ahead and run this one more time. And like we predicted, the 0th index is going to be the string index of 2. In other words, that's where we find our first match. And the index 1, or the second value, our second match, is found at 4. And so let's test our other example. We said that we wanted to test our IEEE meeting, and we want to test the substring EE in it. And just like we predicted, if you take a look in our notes, 1 and 6. So all in all, Not a bad example. A little bit of a mistake in our logic, a rather amusing mistake in our logic. It's always good to be careful when you're dealing with this type of what I like to refer to as negative logic, meaning that essentially you're peeling away the incorrect options. You want to be careful about how you word it. In this case, it just accidentally got us here. Hopefully you found this example useful. And now you know how Microsoft Office, your browser, etc., can pull off the Control F or the find function, because essentially that's what we've built here. So hopefully you found this video useful. As always, if you've got any questions, comments, don't hesitate to email me. Thank you very much.